are not your son. You're not my father.
We diff the return value from previous account. As efficiently as possible reliability. We diff return value from
By now you've learned that you can build components in React to develop user interfaces. But how do you can build components in React to develop user interfaces? By now you've learned that you can build components in React to develop user interfaces. But how do React components turn into the elements on the web page that you see? Remember, when your web browser receives an HTML page, it constructs a document object model, or a DOM, to represent it. But updating the DOM is considered expensive because it is very time-intensive for the web browser to do so. Every time the browser DOM is updated, it causes the browser to recompute the page. Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain websites still load in no time today. How can it be? Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain how React solves the problem by computing its own virtual DOM. Let's start with how React components relate to the website displayed in your browser. A React component has a one-to-one relationship to an HTML element that is displayed on the web page. But how does React keep track of which HTML elements need to be updated? This is where React's virtual DOM comes into play. When React builds out its tree of components, it builds out its own DOM in memory called the virtual DOM. The virtual DOM is a representation of the browser DOM that is kept in memory. React uses this virtual DOM to update the browser DOM only when it needs to. This ensures that your application is fast and responsive to user input. Let me explain how it works. React checks to see if the HTML components in the virtual DOM matches the browser DOM. If a change is required, the browser DOM is updated. If nothing has changed, then no update is performed. This process is updated. If nothing has changed, then no update is performed. This process is called reconciliation. Let's break down what happens when you update a component in React. Firstly, the virtual DOM is updated. Then React compares the virtual DOM to the previous version of the virtual DOM and determines which elements have changed. The changed elements and only those elements are updated in the browser DOM. Changes on the browser DOM cause the displayed web page to change. In this video, you've learned that React constructs and updates a virtual DOM so that the browser will only update certain HTML elements instead of recreating the entire page.
Changed elements are updated in the browser DOM. Display web page updates to match the DOM, the browser DOM. Just updating the browser DOM can be a slow operation. This process helps to reduce the number of updates to the browser DOM by only updating when it is necessary. But even with this process, if a lot of elements are updated by even pushing the update to the browser DOM can still be expensive and cause slow performance in the web application. The React team invested many years of research into solving this problem. The outcome of that research known as the React fiber architecture. The fiber architecture allows React to incrementally render the web page. What this means is that instead of immediately updating the browser DOM with all virtual DOM changes, React can spread the update over time. But what does over time mean? Imagine con này builds the React builds builds a builds a builds 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 a representation of the browser document object model or DOM in memory called the virtual DOM as components are updated. React checks to see if the components HTML code in virtual DOM matches. Giờ đang tiếp dạo nữa nè.
Planning an application as a series of components can be tricky at first, but after doing
Hello everyone. In this video, we're going to see exactly how React.js works under the hoods. After completing this video, you'll have a general understanding on how to implement a library similar to React by yourself, and have a great understanding of React's underlying architecture. To demonstrate the underlying architecture, we'll use a simple online friends component which was written in pure HTML on the right and in React on the left. The HTML version consists of a single unordered list, where each list item represents an online friend. The React version is similar to the HTML one, except that it encapsulates the list items with a single online friend component, which enables better code reusability. And the first part of this video, I'm going to show you how you can actually implement functional components without React using only HTML and pure JavaScript. Since the list item element consists of only HTML code, you might ask yourself, why do we need JavaScript here? The reason is that HTML is not a functional language, so in order to reuse elements, we would have to duplicate our code. JavaScript, on the other hand, is functional by its nature, and every code snippet can be exported to a function and be reused as many times as needed in the future. Therefore, in the first step, we're actually going to implement this entire HTML code block using pure JavaScript and DOM manipulation commands. And if you're new to the DOM object, don't worry. We're actually only going to use 3 methods in this video. Document.querySelector for selecting an HTML element using a query string, document.createElement for creating a new HTML element, and element.appendChild for adding a child element to a given HTML element. Now let's begin. We'll start by linking an empty index.js file and adding it to our project. Next, we'll grab the root dev element using the querySelector method. Then, we can insert a new div element to it using the createElement and appendChild methods. Using the same logic, we can actually create our entire HTML component using only JavaScript DOM commands. And finally, add our image sources. To check if our JavaScript code actually works, I'm going to delete the HTML code and see if the component still renders. And look at that. In the next step, we're going to further manipulate our JavaScript code to implement React-like components. Looking back at our JavaScript code, we can clearly see that the list item element that represents an online friend can be reused. Therefore, we can create an online friend functional component by exporting the code block above to a separate function. Now that the functional component is implemented, we can reuse it as many times as we want. Again, we'll check that our functional component implementation is working by refreshing our browser. And look at that. We've implemented functional components using pure JavaScript. And now to the exciting part. Let's see how React implemented the same logic. If you're new to React, one of the first questions you might ask yourself is, where is my index.html file? Well, if you open the public folder of a React project, you'll actually see an index.html file. But then another question arises. How come there is no link to our JavaScript file, and this HTML file looks pretty empty? And furthermore, if we open this index.html file in our browser, nothing actually gets rendered. And if we open our package.json file, we see that we actually need to run React scripts to build and start the app. So let's do it. And now that our app is compiled, let's open Developer Tools and check out our compiled index.html file. This time, we can see a linked JavaScript file named bundle.js. It turns out that React uses Webpack to compile all of our JavaScript code into a single JavaScript file named bundle.js. For example, the first part of the bundle.js file contains our index.js file that implements our online friends component. However, looking at the code, we see that it looks slightly different than our original index.js file. The reason is that our original index.js file does not actually contain real JavaScript code, but a syntax created by React named JSX, which upon compilation gets converted to pure JavaScript. You can actually check this for yourself and see how React converts your high-level JSX code into pure JavaScript using Babel's website. I'll now add our React Online Friends component, and you can see that we get the exact same code that was written in the bundle.js file. Now the interesting part. Remember the original index.js file from the beginning of the video in which you created functional components using pure JavaScript and DOM manipulation commands? I'm going to copy the compiled React code over here so we can compare it to our own JavaScript DOM code. I'll remove all comments and restructure the code so we can examine the two code blocks side by side. And you might notice that the two code blocks look surprisingly similar. To make things even more awkward, I'll go back to Babel's website and change the React compiler to the old one. Again, I'll copy the compiled React code to our original JavaScript file and reorganize it. This time, the compiled React code looks even more similar to our original JavaScript DOM code. And we even see that both React and the DOM document object use a createElement method to create new HTML elements. It turns out that React has implemented their own virtual DOM, which similarly to the regular DOM is capable of producing every possible HTML component. So finally, the last question we're left to answer is why did React implement their own virtual DOM instead of just using the regular DOM like we did? Well, to answer this question, let's look back at our online friends component. And let's say we want to dynamically add new friends to the list. With a pure JavaScript code, the whole component will have to re-render each time you want to dynamically add a new friend to the list. On the other hand, React utilizes a smart update mechanism that makes sure that the minimal number of changes are made in the DOM in order to re-render a component. According to React's documentation, this can produce a time complexity improvement of up to 3 degrees. For those of you who'd like to continue reading on React's virtual DOM, I'm going to add a link to this page in the description. I'm also going to add a link for downloading the code used in the video in case you want to play with it a little more. Thank you for watching this video.
React is a very popular JavaScript library with over 5.5 million weekly downloads. React is enjoying great popularity, but not a lot of React developers know how React works under the hood. In this post, I'll try to uncover some interesting things about React which you as React developer might find fascinating. Let's start at the beginning. But before we start, if your React Your React developer, I have some exciting news for you. Once you complete this article, you will get to develop something cool with React and green prize on the way. What does React do? That is very cool. React basically maintains a tree for you. This tree is able to do effective computation on a node. Think of your HTML code as a tree. In fact, that is exactly how the browser treats your DOM. Your render HTML on the browser. React allows you to effectively reconstruct your DOM in JavaScript. Push only those changes to the DOM which have actually occurred. Don't want me to be overloaded.
Doing it a few times, it'll become easier. You've already learned about the core internet technologies, and now you know that JavaScript libraries in React allow you to develop user interfaces much faster. Isn't it cool that you can develop user interfaces so quickly? In this video, you will learn how the component hierarchy works in React. Every React application contains at least one component, the root component or app component. Components are added to the app component to build out a tree structure of components that make up the application. Let's explore an example of how an application might be structured as components. Suppose your application is a shopping list of items that need to be picked up from the grocery store. At the root, we have the app component. The app component has two child components, new item bar and shopping list. The new item bar component allows us to add new items to the list. The shopping list component contains a shopping item child component for each item in the shopping list. Even though the item itself might be different, such as chicken or noodles, it is displayed in the same manner as other items. Therefore, you can reuse the shopping item component to display multiple items. When a user ticks off the items, the list will update and remove the corresponding shopping item child component from the shopping list component. Now that you understand the component hierarchy, let's explore how a website can be broken down into components. As an example, I will talk you through a typical blog website. Normally, there is a heading, a menu, and a search bar. You also usually have a featured blog post that displays larger than previous blog posts below it. Now, let's unpack the component hierarchy. At the root of the component hierarchy, you have the app component. This is the entire web page. The app component has two child components, the navbar component for the navigation bar and the page component. The navbar component contains the title of the blog, navigation links for the website, along with the search component. In the page component, we have three components, the main feature component and two instances of a small feature component. The main feature component displays a blog summary about a specific blog post. In the small feature component, there is a blog summary and a thumbnail component to display an image associated with the blog post. Notice that the small feature component is used twice. It is the same piece of code, but for the second small feature, the code uses different properties. And that is exactly the benefit of building a website with React components. You can reuse code for multiple sections, using a series of components to build an app. You've reached the end of this module on UI frameworks. It's now time to review what you've learned during these lessons. Over the course of this module, you've explored the concepts of UI frameworks and libraries and covered an introduction to React. Let's recap the key points you learned and the skills you gained. You began the module with an introduction to UI frameworks. Following the completion of this first lesson, you should now be able to utilize CSS and JavaScript libraries, demonstrate a high-level understanding of dependencies, package managers, and JavaScript bundlers, and explain the key techniques and concepts of responsive web design, such as screen resolutions and fixed and fluid grids. You should also be able to Develop a simple Bootstrap website with the use of HTML and CSS. Utilize Bootstrap's CSS library, including deploying class infixes for responsive breakpoints and class modifiers to change your CSS code, and demonstrate an understanding of Bootstrap's grid system by building a web page using the Bootstrap grid. Following your exploration of UI frameworks and libraries, you then covered an introduction to React and the JavaScript library for building user interfaces. Now that you've completed an introduction to content, page application is, how it works, and how to outline the purpose of React web application script library. Explain the concept of the React component model and identify examples through the virtual DOM, React and React Native, basics of UI frameworks and libraries, and the basics of React and React Native. Excellent. You've made great progress. In this course, you were introduced to the foundations of web development. Let's do a brief recap of what you covered. Module 1 was Get Started with Web Development. In this first module, you learned about the different types of web developers and the roles and responsibilities of front-end, back-end, and full-stack developers. You gained knowledge about the core technologies of HTML, CSS, and JavaScript, and explored the concept of how the internet works. The module also featured an example to show what a day in the life of a web developer is like. Next, you learned more about web pages, web servers, and web browsers, and how they all work together to create what we call the internet. You covered what happens when you send a request to look for something online and how that information gets back to you. Then, you were introduced to core internet technologies and how they interact. You explored some web browser tools that you can use to help you code more efficiently. Finally, you learned what an IDE is and how it can help you speed up your work to write code. In Module 2, how to create an site, used to display the content that you see, accessibility, and some assistive technologies available to provide universal access to the improved web accessibility device. It's available to access to style web pages, alignment, to make you then, in Module 3, introduced to the Get Started alternative UI React. You learned why it was created by meta engineers, component hierarchy, and some alternatives to React.
Hello, everyone. Welcome. This mic thing is really weird. I'm not used to mics. I just hear echoes everywhere. How does my voice sound? Awful? It's good? Great. Cool. Welcome to Facebook. Thank you all for coming out. I'm Tom Okino. This is Jordan Walk. So we're going to get started here, as long as everybody's all settled in. Does everybody have a beverage or whatever? Feel free to get up in the middle if you have to and get some more beverages. Beverage. Hello, everyone. Welcome. This mic thing is really weird. I'm not used to mics. I just hear echoes everywhere. How does my voice sound? Awful? It's good? Great. Cool. Welcome to Facebook. Thank you all for coming out. I'm Tom Okino. This is Jordan Walk. So we're going to get started here, as long as everybody's all settled in. Does everybody have a beverage or whatever? Feel free to get up in the middle if you have to and get some more beverages and snacks. So again, I'm Tom Okino. And today we're going to talk a little bit about a JavaScript framework we built at Facebook called React. And the whole purpose of this framework, or the reason that it came about, is because there's a lot of about is because there's a lot of internal discussion in various, various teams and everywhere else about how should we structure JavaScript applications? And more specifically, how should we structure JavaScript applications that run in a web browser? And there's a ton of different answers to this question. And some of them are up here on the screen, okay? There's a lot of JavaScript frameworks that try to answer that exact question. How should we structure our JavaScript applications? These frameworks have allowed us to kind of move forward as a platform. Like the web can actually now build real apps. Like you can build things that feel good now. Is that MVC is the right way to do this, And it's not just MVC, right? It's, model view view model. And it's, as Angular calls it, it's model view whatever, right? One thing, they're at the heart of all frameworks. Has some events, thing that you just